that's on.
I think we're here. I think we're live. Good evening, everyone. Thanks for joining us. I'm Charlotte. I'm the marketing manager at Salamander Pumps. We are joined by Mike.
Yeah.
Mike's our training manager here at Salamander. And tonight we are going to be talking all things boosting water pressure with centrifugal force. So I'm going to pass over to Mike, who's going to be leading the presentation this evening. It's lovely to see already that we've got plenty of people in the comments saying evening. We hope you're all well and I hope you enjoy the presentation.
Brilliant. Yep. So start the slides off. Yep. So basically, we're here today to talk about boosting water using centrifugal force across our RP range. So right pumps, the pumps in our right pump range use centrifugal force to increase water pressure to the whole house, to deliver the most powerful and quiet performance of pumps in our range. They're suitable for use with up to 8 outlets, including showers, baths and basins, so a whole house range. But why choose the right pump? The right pumps have multiple impellers. These centrifugal impellers are stacked to create high pressure and flow. So more water is moved at the same pressure compared with one of our regen pumps, and higher pressure is maintained at a greater flow rate. You can use them on a whole house, making the right pumps ideal for multiple outlet installations. The centrifugal operation is basically how the water enters the pump. So it comes through the center of the impeller and is spun outwards, creating high pressure within the chamber. They're quiet in operation because they use centrifugal technology, which boosts the water pressure and flow powerfully and quietly. Why choose a right pump? Right pumps are the most powerful and quietest in our range. They feature the UK's quietest twin shower pump, which is the RP50, at 45 decibels. They're more flow efficient than regen pumps and available in 1.5 bar all the way up to 3.6 bar. They'll come in positive head and universal, which is negative head, and twin and single variants. They all come with a 3-year manufacturing warranty. The quiet mark there means that the pump's been tested itself at university, and all the pumps with that quiet mark are the quietest of that type in the range on the market.
That's right. We're going to cover a bit more detail on the range of models that we've got a bit later on in the presentation. So you'll get to know a little bit more about what models we've got, what variants they are, and what they're really suitable for, and kind of the applications that you can use them for as well.
So what's centrifugal force? So it's actually from Latin. It's centrum, which is center, and fugere, which is to flee. Obviously, Italian wasn't my specialty. Used to describe when force pushes objects away from the center of the rotation. So imagine in the diagram there, one of the fairground rides where it spins round, and as it spins round, you move outwards. It's exactly the same as the way the impeller and the centrifugal pump pushes or forces the water around the center of the pump. It flees from the center, which is centrifugal.
We had quite an in-depth discussion this afternoon about different examples of when you can witness centrifugal force. So one of the more obscure ones was a centrifuge machine
in a hospital.
In a hospital. Say that 5 times fast. But all the ideas that we came up with were something that you could experience, where you could really feel that force that pushes you outwards.
From the center,
so something that I always think of is those merry-go-round rides where you somebody runs around and pushes the thing, and it spins round, and you can feel the force pushing you outwards, and that's
exactly how it works. Yeah, that's exactly what that means. So just a little animation there, just to show you, as the water comes through the pump, obviously the impellers, as they're turning, throws the water from the center outwards. So obviously, as it moves along the pump, the water's being pulled through the center and then pushed back outwards using that centrifugal technology. As you shown in this diagram as well, the water comes through, and obviously, if it's a multi-stage pump, it happens in each section of the centrifugal pump. It's creating a high pressure and forces water from the chamber to the outlet. I've actually got, which is probably easier to show, the pump itself. It's down there. Can you see that?
Tip that down a bit and you can see it properly.
So this is a 3-bar pump, one of the right pumps, positive head pump, and you can see the impellers inside there. So as the water enters the pump, the water comes through the center of the impeller, and as the impellers turn, the water is hoisted out and thrown against the side, and then it goes through each stage plate until it gets to the end, and then it comes through the outlet. It's pretty easy. The impellers themselves, that's the impeller that's in there. You can't really see in this light, but inside the vanes are designed to cup the water and throw the water outwards.
Yeah, you can see that they're like kind of arced like that.
Yeah. Imagine just cupping the water and throwing it around there. So that's the impeller for the centrifugal. It differs from the impeller that we have on our regen range, which you can see is a bit like a water wheel, and that turns. The way the regen pump works is the water's thrown around, but then hits a stripping block. As it hits the stripping block, that's how it's pushed out of the pump. But it can make a high-pitched whine in the way that it operates as it hits that stripping block. So the centrifugal pump is a lot quieter in operation because it's using that centrifugal technology. Yeah,
so the centrifugal, just going back to this, if we have a look at that. So if the water's coming in here and it's flooded within here, isn't it? So
there's more water being used in that space, so it's an efficient pump as opposed to the regen model.
So and you can't like stack the multiple impellers for a regen pump. There's just one impeller.
That's right, yeah. So you get multi-stage, so depending on what bar pressure you want would depend on how many impellers you have. So if you have the 1 impeller, 2 impeller, you're going from 1 bar, 2 bar, 3 bar, and so on.
So that builds the pressure as you add more of the impellers. Interesting. So there's no need for any kind of stripping action as part of a centrifugal pump. It's all a force. The centrifugal force basically helps it to push the water out of the pump.
That's it, yeah.
Cool. We'll go back jump back on the slides and we'll have a look at what's coming up next.
If there's any questions, obviously just hold the questions down the side there. And if we miss any, obviously afterwards, we can come back to you. There'll be some time at the end to do that. So Charlotte just mentioned there's multi-stage pumps, there's twin pumps, there's single pumps. So we do a twin positive head pump, ranging from 1.5 bar to 3 bar. They're only suitable for a positive head system. So if you've got a positive head gravity system, then you can use the positive head pump. We'll go on a little bit more later on about positive head and negative head. You can't use a positive head pump if it's a negative head system, and we'll explain why just in the terms of how each pump works. We do twin universal pumps from the RP50 TU all the way through the 100 TU, which range from 1.5 to 3 bar. And they're suitable for positive and negative head. So universal is sometimes described as negative head. But yeah, if you're not sure and you're not sure how to measure your flow rate, or you're not sure if you've got a positive and negative head system, then a universal pump will work regardless if it's a positive head system or negative head system. We do the single universal negative head pumps as well. So the RP55, the RP80 and the 120 SU, and they range from 1.5, 2.4 and 3.6 bar. So what's positive and negative head pumps and how does that affect which pump you choose? So a positive head pump requires a litre every 30 seconds of water, natural flow of water to come in and activate the pump. There's a float in each side of the pump. And obviously when your natural flow of water lifts that float, the pump kicks in and that's what activates the pump. If you haven't got a natural flow of 1 litre in 30 seconds minimum, then the floats won't lift and your pump won't kick in. So just obviously by tipping this pump upside down, I'm forcing the floats to activate the pump.
We'll jump off the sharing so you can really see that demonstration a bit closer. It's quite a good one to show. So this is a positive head pump. Yeah.
So got 2 floats in each side, hot and cold. So basically when your water comes through the pump, imagine that's pushing the floats up and that's what activates the pump. And when you shut the outlet off, the floats drop and the pump cuts out.
Yeah. Interesting.
Yeah, Paul will explain at the end about the warranty and registration that's absolutely fine. Yeah.
So just another question just from me is on the positive head pumps, you say there you need 1 litre and 30 seconds to activate or 2 litres per minute.
Yeah.
So is that on your hot or your cold or on both sides or just one side?
So you need 1 litre and 30 seconds hot and 1 litre and 30 seconds cold, depending on which you're opening the outlet, hot tap or cold tap. If you've got a mix, you need 2 litres a minute or
Excellent. And what was I going to say? How would you be best to measure that?
You can use a measuring jug and a stop clock, or you can use a wear gauge to measure your flow rate coming through. Measure your flow coming through the outlet of the outlet that you want to pump.
Yeah. And obviously you need to make sure that if you're going to measure it for the cold, you've got to turn it all the way to the cold and then all the way to hot as well. Yeah. Cool.
So basically the negative head or the universal pump operates by sensing a drop in pressure on the system. So if you open a tap and you've only got a drip or trickle coming through, there's a small expansion vessel on top of the pump, on the negative head pumps, and visually that's how we tell the difference. So the ones with the negative head pump have the vessel on top, the positive head pumps won't have that vessel. What happens is after the pump's been used, it runs on slightly, and that charges or primes the system afterwards. So as soon as you open that outlet, the pump's going to sense the drop in pressure, and that's what kicks in. So you're not relying on the flow rate and natural flow of water. It works on sensing a drop in pressure on the system when an outlet's opened.
So it kind of acts like a buffer, doesn't it? The pressure vessel.
Yeah, in a way, in a sense, yeah. Talking about twin pumps and single pumps. So when you use a single pump is just if you want to pump either the hot or the cold. Use a twin pump to pump both the hot and cold. Don't use the twin pump and blank one end off because you get closed head running. You can use single pumps to pump only the hot, say, on a gravity fed system. If you're having a problem with the hot pressure in the property, you might have good cold mains, but you want to pump the hot, so you can improve that by using a single negative head pump on the hot. So,
and then what instances might you use a twin pump?
So a twin would be if you want the hot and cold at the same time. So you've got a mixer shower, you've got a standard gravity fed system, and you want to boost both the hot water coming out of the hot water cylinder and then obviously the cold to match. If you've got a single pump, then obviously the size of the pump would depend on your incoming mains. Right. So you'd select the size of the negative head pump on single to increase the hot, depending on what cold mains you've got coming through.
So you need to just make sure that you balance that sort of the supplies so that they can be, one doesn't overrun the other.
Exactly.
Interesting.
We do super booster packs, which is basically 2 single pumps. We do the RP80 SU and the 120 SU. You can split a larger system. So if you've got a big gravity fed system and your cold tanks at one side and your hot cylinders at the other, rather than go to the trouble of repiping everything and redirecting it, you could put the cold under the cold water storage tank to boost and the hot at the hot water cylinder. So larger systems, it's a bonus to get the 2 pumps that way.
And are they good for situations where, say, you might be doing a lot of closed head running? Say, for example, you might ordinarily have chosen
if you've got a twin pump
that's boosting, I don't know, to maybe a lot of electric showers. Would you maybe
if it's going to be used all the time, then I would suggest 2 singles rather than a twin pump. Yeah. It's a fun bit. So it's competition time, and there's a chance to win a £30 Amazon voucher. Just a little thank you for watching so far. The question? We've got a question. In the chat, so just in the chat there, and Charlotte will keep an eye on the chat.
Yeah.
Tell us. A negative head pump is often referred to as a watt pump. We've mentioned 2 words that can describe a negative head pump. So just pop your answer there in the chat. The first person that gets the answer right, we'll send that £30 Amazon voucher out to.
We're getting some answers already, getting them in.
Yeah.
Yes, we've got the correct answer there. The first one was from Levi, who said a universal pump. So yeah, can you maybe explain why do you think a negative head pump could be called a universal pump?
I think the universal pump, it's because it's going to work regardless if it's a negative head system or positive head system. So it's universal, it's suitable for both.
Yeah.
One thing we do get asked is our old range of pumps, the ESPs, the right pumps, you could set them to be in the positive head or negative head.
Right.
So the universal pumps, the new RP range, basically they've got a float in there and they work on the pressure drops, so it'll work regardless. It's it's universal.
So you don't have to set anything.
You don't have to. You don't buy. You don't have to buy the negative head pump and then set it into positive head. If it's a positive head system or part of the system or positive head, it will just sense the drop in pressure or the flow rate naturally.
And that probably brings us on to a question that we would hope that everybody might know the answer to is, would you be able to install this pump directly to the mains?
No.
No?
Definitely no. No, don't fit any gravity pumps to the mains. The mains pressure on the cold side of one of these pumps will damage your pump. You'll blow the body O-ring out with the pump there. So we'll have a mains range of boosting solutions. These are gravity fed, so just make sure it's from a cold water storage tank and a hot water cylinder, gravity fed systems only for the RP pumps.
Great. So yeah, there you go. The answer was universal.
So we talked about the impeller earlier on. The impeller, as you can see, it's designed, it's sonically welded to efficiently pump water around the inside of your pump. What can happen is as hot water temperature rises in your hot water cylinder, the bubbles gather around the side and the top of your cylinder. So if you take that into your impeller, obviously the small veins inside of there, the way the impeller works, any aerated water and any air bubbles will get trapped into the impeller itself. So you'll get impeller breakdown through cavitation issues.
Yeah.
So to protect your pump against cavitation from aerated water, you must use a suitable flange or an anti-aeration device. And you must use a flange on all the RP range just to maintain your manufacturer's warranty, basically to get the lifespan of your pump.
Yeah. Is it fair to say that a centrifugal pump is more susceptible to damage to cavitation by air?
It is,
than a regen pump?
It's the design of the impeller. On a regen, normally if there's any air in there, it's pushed out
quite quickly.
And it's more
makes a lot of sense,
solid,
doesn't it? Really, if those pumps.
It's a chambers
like a regen
inside
pump,
as well, yeah. So
with a regen pump, it's very quickly whipped. Everything is whipped quite quickly out of it. Whereas with a centrifugal pump, the air could be rattled around within the pump.
It finds a hot escape. So once you get any air bubbles into the centrifugal impeller, it gathers at the corners, and what happens is the plastics inside that are sonically welded start to break and deteriorate, and it cracks, and then you'll damage your pump. So it's really important that you fit a flange to prevent any aeration issues on the pump. So you can do that. There's a few different methods. That one there is the S flange. It's a top entry flange. And basically the dip tube at the bottom there passes the top shell of the hot water cylinder. So it's taken unaerated water from the body of water inside the cylinder rather than the aerated water that gathers around the side and around the top. And then the aerated water, the air bubbles, basically harmlessly pass up into the open vent through the top of the S flange. And then you've got your 22 mil air-free supply down to your pump for your hot supply to your pump.
Yeah.
A little bit of advice, we do have people fitting top entry flanges, and there's a Warwick's flange and there's an S flange, and they both look quite similar in design. However, the connections from the flanges are opposite. So on the S flange, the top connection goes to the open vent and the hot feed to your pump is off the side.
Yeah.
The connections on the Warwick's flange are reversed. So the hot feed to your pump comes off the top and the side goes up to the open vent.
Right. So it's really important to make sure that you get those the right way around.
Yeah. If you fit the Warwick's flange the same way as an S flange, which people do, you're potentially dragging all the aerated water straight in your pump. So you're defeating the point of actually putting one on anyway. They both come with the fitting guides which tell you which connections, which is again just
make sure you
refer back to that. Yeah, definitely.
Is there any reason why you would choose one over the other?
No, I mean, they're both top entry flanges. You can change the position on the Warwick's flange so the center actually turns around, so it makes it a bit easier to connect there. But it's more important that you get the connections right on there as well.
Yeah.
The other option would be a NonStop S6, so not an S6 flange, a NonStop S6 flange, to make sure that the feed from the flange itself goes past the side of the cylinder and takes water from the body of water inside the cylinder there. Obviously, you've got to drill the cylinder. A lot of plumbers don't tend to do that or don't like to do that, so they'll fit a top entry flange. The problem is if you haven't got the space between the top of your hot water cylinder and your base of your cold tank, then you need about a meter, 1.2 meters between the two. Then potentially you can use a top entry flange and still get aerated water in there. If you fit the pump above the dome of the cylinder, then we do recommend that you use an anti-gravity loop via a NonStop S6 flange on the side of the cylinder, not a top entry flange if the pump's above the dome of the cylinder.
So in what circumstances do you need to make sure you've got that gap between the top of the cylinder and the cold water storage? Is that in all cases you need to make sure that you've got the 1.2 meters? You
do, yeah. And obviously, if you're going to fit a flange, fitting the top entry flange isn't the right flange. You need the Essex flange.
So if you've got any less than that, you need an Essex flange.
Yes. Yeah. A lot of people don't like doing the Essex flange, but it is the best method.
Yeah, and it's required, isn't it, if the pump is located above the hot water cylinder?
Yeah. A little bit of installation. Obviously, everything that's going to help you for the installation is either on our website. It comes with a little handy book that comes with the pump. It's called the installation guide. Just make sure I have a quick read through that. All the hoses must be straight. So we do see pictures of hoses
bent in every different direction.
Yeah. On a positive head pump, what you're doing first of all is you're going to restrict the flow of water into the pump. So you probably get activation issues. So keep them straight. The other point is we call them hoses, the anti-vibration couplers, and it's to prevent any vibration when the pump's in use transferring along the pipework. So keep them nice and straight at all times.
And minimising that vibration is only going to help the homeowner, isn't it, to make sure that the installation is as
quiet
as possible.
Noise is something the customer wants to be quiet. You've got a centrifugal pump, which is quiet. Don't then bend the hoses and then make the pump noisy. Yeah.
So within a hose, there's like a hose within the sort of metal braiding, isn't there? That can
you basically get the outlet.
We've got a hose just to the side here, but it's attached to a pump, so we'll just quickly remove it. There it is.
Got your outlet braid.
This one we prepared earlier.
You've got your braiding on the hose, and obviously inside there you've got your smaller diameter pipe.
Yeah.
Keep them straight. If you bend the hoses too much, you can see kinks.
Yeah.
And straight away you're
limiting, aren't you?
You're limiting it. Imagine a garden hose. You're squeezing a garden hose. You reduce the amount of water going through, so you get activation issues. You'll also be pumping out, and then you'll be starving the pump because you'll be reducing the amount of water going through. So keep them nice and straight. We don't just say that because it looks pretty. It will affect and damage the pump.
Yeah, it can damage the performance and it'll reduce the longevity of the pump.
Exactly. Yeah. Pipe size, 22 mil feeds for all of the RP range. Maximum of 5 meters measured pipe work from there. The exception is the RP50, which you can have a maximum of 2 meters and 15 mil. Basically, if the pump comes with 15 mil hoses, you can have 15 mil, but a maximum of 2 meters, in measured pipe work. If it is at RP50 and you want to take 22 all the way and then just reduce down as it goes into 15, that's absolutely fine as well. Cold water storage, a lot of people underestimate how much cold water storage is needed. As a rule of thumb, it's 50 gallons per bathroom and 30 gallons per ensuite of usable cold water storage. So not the size of the tank, the actual measured water inside the cold water storage.
It's particularly important for right pumps, isn't it? Considering that they're more flow efficient, so they're going to move more water.
You've got a 3-bar pump, it's going to take more water. So if you haven't not used to having a pump in there and you've got a small cold water storage tank, which is fine for that gravity system, you put a 3-bar pump in, you're going to clear a lot of water out there, and you're going to have to try and replenish the hot water cylinder as well. So you need to make sure you get the cold water storage capacity right.
Yeah.
Maximum temperature passing through the pumps on the hot side, 60-65 degrees, maximum 65. Usually controlled by a cylinder start.
Yeah.
If you haven't got a cylinder start, then you can fit a thermostatic mixing valve, a TMV. The Salamander one comes preset, so it's not going to exceed that 65 degrees. And again, it's just to protect the pump. If you don't fit a flange and you get aerated water, and they don't fit it means temperature control, you're going to get aeration and cavitation speeding up because you've got higher temperature and you've got high aerated water. So yeah.
We've touched on noise and making sure that the installation is quiet as possible. Is there anything else that an installer can do as part of the installation process that can help the pump be really quiet, as quiet as possible?
Clip your pipework, follow the installation guide, fit it correctly. You have, we offer pump mats if you want to put the pump on. So sometimes people put it in an airing cupboard at the base of the hot water cylinder. So there's a little bit of noise transfer because you've got a void underneath that. So fitting a pump mat as an accessory under the pump will help reduce that transfer noise as well.
Yeah.
Again, keep your hoses straight.
Making sure they fit the feet as well, that'll help as well.
Yeah, if it comes with the feet, put the feet on there as well, yeah.
Great.
Another thing you can do if you're unsure, so obviously we're talking about single pumps, twin pumps, positive, negative head. There's a lot to take in half an hour. So go on our website. There's a great tool on there for product selector software. So it'll ask you what kind of system you've got on this with the gravity fed systems, and it'll recommend a size of pump, and it'll tell you if you need a negative head or positive head pump. We also have all the downloadable content that comes with the pumps available on our website, and we have an online chat facility and a really great technical team here at Salamander Pumps who are all technically trained in all the product range, which is including obviously the RP range. So any questions, give them a call or visit our website, salamanderpumps.co.uk.
Yeah, there's loads of videos, FAQs, articles, how to install, all the key top tips, everything on the website. So if you've got any questions, that's your first place to try and find the answer. But if you need any more additional or more in-depth support, obviously Salamander is here to help, and just get in touch.
We also have, you've got a website for installers. We also have an e-school, an e-learning school. There's modules on there. It's all free. You can do it in your time. Take as long as you need to do it. You get a certification to say that you've read the module or you've studied the course, and there'll be a little quiz at the end. It's really good as a reference tool. So you might have been fitting these pumps for years, and then you just want to know a little bit more information on there, and help you explain if you asked, or help you understand why and how the pumps are built and the benefits of each one.
Yeah, definitely. And you can always jump back in at so once you've gone all the way through the course, you can then jump back in at the different stages, can't you? And say, for example, on there, you can look at all the different parts that go into the pump, why you might choose one over the other, and the different features and different requirements that you get with each.
Yeah. At your own pace and in your own time. Just like I say, it's great. The FAQs, I think we've tried to answer as many questions that we've been asked on the phones and emails. So the FAQs is a really good starting point, either pre-installation or if you're having, if you're going out to see look at a pump, start with FAQs.
Yeah, definitely.
Points in the right direction.
So we'll just jump off the slides there and go into some questions. I think there was a couple that came in while we were chatting. So we've got a question from Jason. Using a single universal pump, if the cold mains cannot be exactly matched, is there a ratio that's acceptable?
I'm not sure if the ratio is acceptable, but basically if your mains coming through is higher and you're on a mixer tap, then the pump that you choose a 1.5 bar pump, you'll have activation issues because you're going to be constantly fighting against that cold mains coming in. So it's worth measuring your cold incoming mains and then choosing the pump that's as close to that as possible.
And just touching on Paul's comment about registering warranties. So there's two ways you can register your warranty. The first is on our website. So on salamanderpumps.co.uk, there is a online warranty registration page where you can complete the details and submit that to our team. We can also you can also register it online as part of the loyalty scheme. So if you want to join our loyalty scheme where we give points to installers for registering their pumps, you can do it on there as well. Or you also can ring into our desk on 0191 516 2002, where a member of the team will take the details from you and register the warranty that way.
Nathan, so basically 50 gallons tank for a bathroom and 30 gallons for a shower. Same as the advice for the CT range of pumps as well that we have. Steve Thompson, when using on the WC, would not be better using a universal pump. So yeah, a universal pump is best if your outlets are restricted, so body jets, toilets, anything that's not a great flow of water to initiate the pump, you'd be best off going for a negative head pump. What's about flexible hoses if they have to be installed straight? Just because I was saying, Karen, there is a little bit of give on them. So we do actually say there's maximum 35 degrees. The problem is sometimes 35 degrees becomes 45 degrees, becomes 90 degrees. And what happens inside there is you're restricting the flow of water going through, so you're crushing the pipe there.
Yeah.
So and we do see them as bad as that as well, and then wonder why the pump's struggling to activate or it's starved of water. So they're not flexible hoses. You can flex them. They're meant to be kept straight. They're anti-vibration couplers.
Yes. So if you needed to make a warranty claim, there is a process that needs to be followed, and as part of that, the installation images would need to be provided to validate information such as making sure that the hoses are straight, making sure that adequate hot water protection is in place, and all that sort of information would need to be provided.
Yeah, I think, Paul, the picture evidence it's just basically for the guys on the phones there that can't see the installation, so they just want to make sure, say if you've got a flange, it's the right flange. If the hoses are bent or twisted, we can give advice over the phone. If we can see the installations, that usually helps us help you.
Yeah.
Thanks, Richard. Cheers.
Is plastic pipework better to reduce noise?
You can fit the pumps with plastic, or supply the pumps with plastic or copper. Obviously the copper pipework, the noise, if it's noise transfers, it's copper as opposed to plastic. I think it depends on your preference. To be fair, no plumbers personally like to use copper. Other plumbers through speed want to use plastic. But providing you've got the right size, either plastic or copper pipework, and it's clipped and there's no strain on the pipework, then that's acceptable. Yeah.
And I think we've probably got time for one last question. Just aware that we've tipped over after 7 o'clock. But can I run a CT60BU on bath, shower and basin? I think that would be possibly too many outlets for a CT60BU. I think we say that a 60BU can be used on 4 outlets, which would include each hot and cold. So it would be like a hot tap and a cold tap on a bath, plus a
depends on shower head size and things like that as well. So it depends. If it's normally the more outlets, the bigger size pump that you would need.
Yeah.
Thanks, Terence.
Yeah, thank you for all the questions that we've had and for all your engagement tonight. It looks like there's plenty more questions coming through. So if you keep dropping them in the chat,
we'll get them anyway. So
we'll continue to get them and make sure that we get a response put up to everybody in the next couple of days. So again, thank you very much for joining us.
Thank you very much. It's been great. And like I say, if there's any questions or web page or email address, just drop us an email. We'll try to come back to you as much as we can. And well done to the guy that won the voucher as well.
Yeah, well done. And thanks, Gavin. I am looking for a new job on this morning, so it's always worth having that on the back pocket. So never mind. Thanks very much for joining us, and we'll see you all soon. Thanks. Bye.
Thank you. Cheers.